Quicksort is the algorithm that powers real-world sorting in most programming languages, not bubble sort, not merge sort. Quicksort. The reason comes down to one brilliant idea called the pivot. Here is an unsorted array of 30 elements. Quicksort picks one element as the pivot. Every other element gets compared to it and placed on the correct side. Elements smaller than the pivot go left. Elements larger go right. After one pass, the pivot is in its exact final position, permanently. It will never move again. Now here's where it gets powerful. Quicksort does the exact same thing recursively to the left half and the right half simultaneously. Pick a pivot on the left section, partition around it. Pick a pivot on the right section, partition around it. Each pivot, find its permanent position. Each pass shrinks the unsorted section smaller and smaller. Watch the red pivot elements locking into their final cyan positions one by one. Notice how the sorted section grows from multiple points at once, not just from one end like bubble sort. This parallel partitioning is why quicksort feels so fast in practice. While bubble sort makes one element correct per full pass, quicksort can lock multiple pivots into positions simultaneously across different sections. Quicksort achieves O(n)log n average time complexity, same as merge sort. But in practice, quicksort is often faster because it sorts in place. Unlike merge sort, which needs O(n) extra memory. Quicksort only needs O(log) n stack space for the recursive calls. The one weakness is worst case performance. If the pivot chosen is always the smallest or largest element, quicksort degrades to O(n)². That is why modern implementations use randomized pivot selection to avoid this trap. Pick a pivot. Partition. Recurse. The algorithm that runs inside your programming language every time you call sort.